Hey, good morning, YouTube, and Happy New Year. Stephen Fleet here. Hey, I wanted to go through a little bit of work I've recently been doing. Um, so, past videos I've posted about y equals 3x plus z. We're going to change the notation here to be g equals 3y plus z, just so we don't get the variables confused. And z is this function, which just causes it to alternate between plus 2 and plus 1 and plus 2 and plus 1. So what's interesting is that this will produce all of your primes and then also semi-primes and also composites within it. What's important is that all your primes, it doesn't skip any primes. So now what you can do is you can actually predict the locations of the semi-primes and the composites themselves. And that's what this matrix C is. And so you use a series of equations. So you have this first equation. So if you iterate n equals 1, y equals 8, n equals 2, y equals 16. And then you go to the next equation, y of 2, where y of 1 goes into it, and then y of 3, and then y of 2 goes into it. And then so y of 4 is y of 3, y of 5 is y of 4. But what's important is that these two functions alternate back and forth. You see y of 2 is the same as y of 4. It's just this last term changes. So what you can then do is create a matrices of these values where n equals 1 is this column, n equals 2 is this column, and so on. And what you get is a matrix or a matrix where the values in between are your primes. So all of these values here, these y values, will be for your semi-primes and your composites. And so you can interpolate, here's a formula for interpolation, interpolate in between these values and you will get primes. So you can predict prime numbers, but you do it by essentially not predicting them directly. It's what's left over. And you can predict the values that are not primes. And so you know for sure that the values in between will be your prime. So for example, if your y value was 9 here, once it goes into this equation, your g value would equal a prime. Okay, thanks. Bye.